Hello, algebra classes. We're going to take a look at our assignment for 9.6c. We're going to go through the guided practice problems, and you don't need to write any of these guided practice problems down. When you get to the lesson 9.6c, you're going to be copying a concept summary chart of the information that we're going to go through in this guided practice. So I want you just to follow along with the ideas that are being presented here in the guided practice. I'm going to ask that you not write any of this down because I think it will go into your brain a little easier if you just follow along with your eyes and your ears as we go through this information about the 5 ways that we've learned how to solve a quadratic equation and when we might use each of those 5 different methods. So there's 5 ways to solve an equation that's in quadratic form. Square root or factoring, complete the square or graph it, and when all else fails, use the quadratic formula. So we have learned 5 ways to solve a quadratic equation. We started by learning how to factor our quadratic equations, either using the GCF method or the quadratic factoring methods that we've discussed at length, or both. Sometimes both of those factoring methods work, sometimes only one or the other one works. But that was our first step into solving quadratic equations. So we spent quite a bit of time developing this idea of factoring to solve quadratic equations. Then we next learned about taking the square root. That's useful when an equation has x squared terms but no x terms, and we'll see an example of that in a minute. That method will not work if there's both x squared and x's. Say you had an equation like 5x squared plus 6x plus 2 equals 0. Well, you wouldn't be able to use taking the square root because it's got both x squared and x terms. So both of these techniques, factoring and taking the square root, work great when the equations lend themselves to those methods because those equations actually can be solved with those methods. Sometimes those methods don't work. And that's when we have some other techniques at our disposal. Another technique that we did learn about and spent a lot of time developing is this idea of graphing our quadratic equations to solve them. And that's a great way to visualize what it means when we're talking about the zeros of a function and how that relates to the solution to a quadratic equation equal to 0. So graphing to solve those quadratic equations equal to 0 sometimes is not an efficient way, and sometimes it only gives you approximate solutions depending on the type of equation you're working with. So this was really a conceptual way to learn how to solve a quadratic equation. It's not a particularly efficient way. Then we learned about completing the square, and we primarily learned about that method of solving a quadratic equation in our step-by-step look at how we solve quadratic equations by the quadratic formula. And that's our last method that we learned about, solving using the quadratic formula. We learned about completing the square, which led us up to deriving the quadratic formula by completing the square. And we're going to want to use that quadratic formula when factoring or taking the square root doesn't work. The next easiest method to solve a quadratic equation, if factoring or taking the square root doesn't work, is that quadratic formula. So these other 2 methods we don't tend to use a lot unless we're specifically asked to do so or unless we have a particular purpose in why we're using them. So our 2 easy methods of solving quadratic equations are factoring and taking the square root. And when those easy methods don't work, we generally jump down to using the quadratic formula. That being said, the quadratic formula can be used to solve any quadratic equation, even when some of the simpler methods are available. All right, let's take a look at when we might want to use some of these particular methods to solve our quadratic equations. So we'll start with example 1. Example 1, I'm going to give you this equation, and we're going to say, well, why is this a good equation to solve using factoring? And it's a good equation to solve by using factoring because it works. We have both a greatest common factor of all 3 of these terms, as well as some quadratic factoring techniques that are available to us. So in this particular equation, first I might want to factor out the 2, and that would give me 2 times x squared plus 5x plus 4 equals 0, because 2 times x squared is x squared, 2 times 5x is 10x, 2 times 4 is 8. Then I might want to divide both sides of the equation by 2, and that 2 and 2 would cancel out, and we're left with a very easy to factor quadratic trinomial here, and here I am using my x method to factor it. And that would give me x plus 4 times x plus 1 equals 0. Using our zero product property and setting each of these factors equal to 0, I can solve those two resulting equations to arrive at the final answer, x is equal to -4 or -1. So this particular equation, if we were given a choice, we'd probably want to use factoring because it's oh so easy to use factoring on this equation. And I've given you an example where both the GCF method and our quadratic factoring techniques can work. Sometimes factoring an equation works beautifully, but only one of those methods applies to a particular equation in some instances. In this case, both of the factoring techniques we've learned about work here. All right, example 2, this is an example of when we might want to take the square root to solve a quadratic equation. We see only x squared terms. We don't see any x terms. We don't see 3x or 5x or 10x. We just see x squared. When your equations have only x squared terms, then taking the square root is going to be a really efficient way to solve that equation. So here I am dividing both sides by 5, getting it down to just the x squared term, then taking the square root of both sides, and x is equal to positive or -3. So taking the square root when we only have x squared terms is a great way to solve a quadratic equation. So our first two examples were the easy methods that work beautifully when they work to solve a quadratic equation, but they don't always work. So now we're going to talk about some of our other methods. Example 3 is this idea of using graphing to solve a quadratic equation equal to 0. And in this case, we're presented with x squared plus 10x plus 25 equals 0 as an example of when graphing might be useful to solve the equation. And in this case, I'm going to replace that 0 with y because I'm going to be thinking about what that quadratic equation would look like in general. I'm really only interested in knowing when y happens to be 0, which is right here, where it touches that x-axis. So we're looking for the x-intercepts of our quadratic equations equal to y to know what the quadratic equation equal to 0 actually is. So here I am figuring out my vertex using my -b/2a. There's lots of ways to graph our quadratic equations here, and I chose using -b/2a to find the vertex because it looked easy. And so here's my table of values based on my vertex being -5. I'm picking my x values above and below that, finding the corresponding y values, plotting those 3 points, and noticing when does this parabola touch or cross over the x-axis. Well, in this case, it only touches it once, so there's only one solution. Here's the zeros of the function when x is -5. Okay, x is -5 because that is the place where the parabola intercepts or touches the x-axis. There it is, one place only. On the x-axis, all the ordered pairs have y equals 0, thus -5, 0. This one point here shows that x is what x is equal to when y is 0. So for this particular equation, when I graphed y equals x squared plus 10x plus 25, I found out where the zeros of the function are when y equals 0. What's my x value? When y is 0, x is -5. So that's how graphing can help you solve a quadratic equation. Great visual method. Example 4, completing the square. So we learned about completing the square in preparation for deriving the quadratic formula. Typically, you're probably not going to use it a lot to solve an equation. There are some equations that are uniquely suited and easy to use completing the square to solve the quadratic equation, but oftentimes those same equations can be easily solved using factoring or taking the square root. So let's just go through an example of an equation that we can use completing the square on fairly easily. X squared plus 2x equals 3. We're going to find half of the coefficient on the x term. That's 1. That's what's going to go in each of these boxes. And I'm going to rewrite my perfect square trinomial I just built as the square of a binomial. I'm going to pull that +1 into the parentheses squared. 3 plus 1 over here is 4. Then I take the square root of both sides. And I'm left with x plus 1 equals positive or -2. Subtract 1 on both sides, giving me x is -1 plus or minus 2. And then x is equal to -1 plus 2. There it is, -1 plus 2. And -1 minus 2. That comes from here, -1 minus 2. And the result of that is the solutions of this equation by completing the square is x equals 1 or -3. Truthfully, factoring this equation, setting n equal to 0 and factoring it would have been easier than completing the square, but we learn about completing the square so that we can derive the quadratic formula, which I showed you the other day in one of your lessons. Example 5 is an example of when we might want to use the quadratic formula. Again, if the two easy methods, factoring or taking the square root, doesn't work, generally we would jump right down to using the quadratic formula, which can work for solving any quadratic equation, but we usually only want to use it when our first two easy methods, factoring and taking the square root, don't work. So here we have a quadratic equation that does not factor, so we find our a, b, and c. We think or sing our quadratic formula here. We plug all of these numbers into the quadratic formula, which you see me doing here, simplifying what's in the radical to 4 plus 48, simplifying some more, so my radical is just 52. Simplify my 2 times 3 to make 6. Then taking this information in its simplified form here and breaking it apart into 2 different separate calculations, 2 plus root 52 over 6, 2 minus root 52 over 6, and then finding out that my approximate values of the solutions to my equation are 1.54 and negative 0.87. So again, that quadratic formula is really going to be useful when factoring and taking the square root. It doesn't work because it's pretty easy to pull off the a, b, and c and throw it all into your quadratic formula and then simplify down to your final values that are the solutions of your equation. Okay, so now it's time for you to move on to the lesson classwork, which is due at 4 o'clock today. And basically this was just a guided practice to kind of get you into the idea of the 5 ways to solve our quadratic equation. So you will literally be copying the concept summary that you see in the book on a piece of paper, adding the 2 sentences that I've asked you to in Google Classroom on the lesson. So you're basically just literally copying what you see in the book, which will be all of this information summarized, and adding the 2 sentences that I've asked you to do into that concept summary, and that's it for the lesson for today. And you're going to hold on to that summary because you'll be able to use it when we take the chapter test after Easter break. All right, we'll see you next time.